Welcome to Herzing University online presentations. The topics covered in this presentation are solving rational equations and applications of rational equations. Let's discuss the steps needed to solve rational equations. First, list restrictions on the variable as the denominator cannot equal 0 or it will be undefined. Then, clear the equation of fractions by multiplying both sides by the least common denominator of all rational expressions in the equation. Next, solve the equation. Lastly, check the proposed solution in the original equation. Let's look at some examples. Example 1. Solve for x. X divided by 5 minus 2/3 equals 1/3. First, list the restrictions. And we do not have any restrictions for this equation because there are not any variables in the denominators. Clear the fractions by multiplying both sides by the LCD of 15. 15 times x divided by 5 minus 15 times 2/3 equals 15 times 1/3, which equals 15x divided by 5 minus 30 divided by 3 equals 15 divided by 3. We can simplify this further and get 3x minus 10 equals 5. Now solve the equation. 3x minus 10 equals 5. Add 10 to both sides. 3x minus 10 plus 10 equals 5 plus 10. Therefore, 3x equals 15. Divide both sides by 3. 3x divided by 3 equals 15 divided by 3, and x equals 5. Check the solution. Substitute 5 into the original equation. 5 divided by 5 minus 2/3 equals 1/3. Changing our fractions to reflect the least common denominator, 15 divided by 15 minus 10 divided by 15 equals 5 divided by 15. Simplifying, we get 5/15 equals 5/15. This is a true statement. Therefore, the solution x equals 5 is correct. Example 2. Solve for x. 3x divided by x plus 1 plus 4 divided by x minus 2 equals 3. What are the restrictions? What values of x would make either denominator 0? If x was -1, the denominator in the first term would be 0, and if x equaled 2, the denominator in the second term would be 0. Therefore, the restrictions are x cannot equal -1 and x cannot equal 2. The next step will be to multiply every term by the LCD, which is x plus 1 times x minus 2. This is the same as multiplying by x plus 1 times x minus 2 divided by 1. Our result is x plus 1 times x minus 2 divided by 1 times 3 divided by x plus 1 plus x plus 1 times x minus 2 divided by 1 times 4 divided by x minus 2 equals x plus 1 times x minus 2 divided by 1 times 3. Now we need to simplify. Notice the x plus 1 term cancels in the first expression, and the x minus 2 term cancels in the second expression. Simplifying, we get 3x times x minus 2 plus 4 times x plus 1 equals 3 times x plus 1 times x minus 2. Distribute the 3x on the left side of the equation and multiply the two binomials on the right side of the equation. And the result is 3x squared minus 6x plus 4x plus 4 equals 3 times x squared minus 2x plus 1x minus 2. Now combine like terms on the right side of the equation. 3x squared minus 6x plus 4x plus 4 equals 3 times x squared minus 1x minus 2. Then distribute the 3 on the right side of the equation to get 3x squared minus 2x plus 4 equals 3x squared minus 3x minus 6. Next, solve 3x squared minus 2x plus 4 equals 3x squared minus 3x minus 6. Subtract 3x squared from both sides, and we get negative 2x plus 4 equals negative 3x minus 6. Add 3x to both sides. Negative 2x plus 4 plus 3x equals negative 3x plus 3x minus 6, which simplifies. 2x plus 4 equals negative 6. Subtract 4 from both sides. X plus 4 minus 4 equals negative 6 minus 4. Therefore, x equals negative 10. Check the solution. Notice the solution is not on the restriction list, so we can substitute negative 10 in for x into the original equation. The result is 3 times negative 10 divided by negative 10 plus 1 plus 4 divided by negative 10 minus 2 equals 3. Simplifying, negative 30 divided by negative 9 plus 4 divided by negative 12 equals 3. The next step is reducing terms so we have a common denominator and can combine the fractions on the left side of the equation. 10 divided by 3 plus negative 1 divided by 3 equals 3. Combining like terms on the left side of the equation, we get 9 divided by 3 equals 3. 3 equals 3, which is a true statement. Therefore, our solution x equals negative 10 is correct. Rational equations can be used to solve many problems in real life. A common application problem that uses a rational equation is a work problem. A business owner may need to decide whether or not it is beneficial to send one worker or a group of workers to complete a work project. An individual may need to decide if it is worth it to hire one worker or two workers to complete a project at home. In either case, we can use the work formula to help us make our decision. The basic work equation is time together divided by time alone, worker number 1, plus time together divided by time alone of worker number 2 equals 1. We use 1 because it's one job. Since time together to complete a task is what is unknown, we can call that x, and we can rewrite our work equation to x divided by time alone by worker number 1 plus x divided by time alone for worker number 2 equals 1. Example 3. Ray and Steve are both yard specialists. If Ray can complete the yard work for the governor's mansion in 6 hours and Steve can complete it in 8 hours, how long will it take them to do it together? We are going to use the work equation and substitute 6 in for the denominator in the first expression and substitute 8 in the denominator in the second expression. Therefore, our equation is x divided by 6 plus x divided by 8 equals 1. Eliminate the fraction by multiplying both sides of the equation by LCD, which is 24. 24 times x divided by 6 plus x divided by 8 equals 1. Next, distribute the 24 to each term inside the parentheses, and the result is 24x divided by 6 plus 24x divided by 8 equals 24. This simplifies to 4x plus 3x equals 24, which is 7x equaling 24. Divide both sides by 7 and x equals 3 3/7, or 3 hours and 26 minutes, which is how long it takes to complete the job together. Rational equations are also used in motion applications. Motion applications involving time use the formula T equals D divided by R, which represents time traveled equals distance traveled divided by the rate of travel. Let's look at an example. Example 4. In still water, a boat averages 8 miles per hour. It takes the same amount of time to travel 30 miles downstream with the current as 18 miles upstream against the current. What is the rate of the water's current? Let x equal the rate of the water's current. Let's set this problem up by using a table. The distance traveled with the current is 30 miles, and the distance traveled against the current is 18 miles. The rate of the boat going with the current is 8 miles per hour plus the rate of the water's current, which is x. The rate of the boat going against the current is 8 miles per hour minus the rate of the water's current, which is x. We are subtracting x from 8 because we are going against the current. The next step is to fill in time, which is distance divided by rate. Recall x equals the rate of the water's current. We need to complete the table by filling in the time for each trip the boat is making. The time of the boat going with the current can be represented by 30 divided by 8 plus x. The travel time of the boat going against the current can be represented by 8 divided by 8 minus x. It takes the same amount of time to travel upstream with the current as it does to travel downstream against the current. Therefore, we can set the times equal to each other and solve the rational equation to find our solution. Solve the equation 30 divided by 8 plus x equals 18 divided by 8 minus x. First, we're going to list the restrictions. X cannot equal negative 8 and x cannot equal 8, as those values would make the equation undefined. Remove the fraction by multiplying both sides of the equation by the LCD. 8 plus x times 8 minus x. The result is 8 plus x times 8 minus x divided by 1 times 30 divided by 8 plus x equals 18 divided by 8 minus x times 8 plus x times 8 minus x divided by 1. The 8 plus x term in the first expression cancels, and the 8 minus x term in the second expression cancels. The equation simplifies to 30 times 8 minus x equals 18 times 8 plus x. Apply the distributive property. 30 times 8 minus x equals 18 times 8 plus x simplifies to 240 minus 30x equals 144 plus 18x. Subtract 144 from both sides of the equation, and the result is 96 minus 30x equals 18x. Next, add 30x to both sides, and we get 96 equals 48x. Dividing both sides by 48, x equals 2. Therefore, the rate of the water's current is 2 miles per hour. This concludes the presentation on solving rational equations.